All right. Happy Tuesday. We are in week 8. So, next week is going to be the last of the new material, believe it or not. So, we have chapter 9 and we have chapter 10. That's it. So, we are in the home stretch. You all are hanging in there. You're doing great. I did get those tests graded. I will, as I just said in the chat, but you guys weren't here for that. I'm not sure why the test results aren't visible. I will click on that. I think you probably can see the grade, but that's it. So I will go in and fiddle with the settings and make sure that you can get in and see what you did wrong. I didn't leave much feedback because I was trying to get those done. So if you have questions about specific problems, you don't know why you got it wrong, make sure to send me a message and I'll go over it. I'm happy to do that. It's not a problem at all. Okay, so today we're going to do section 9.1. So we're going to obtain a point estimate for a population. We've done that before. It's just p hat. We did it before. So, and we're going to talk about confidence intervals. Um, so confidence intervals are going to lead us into hypothesis testing in chapter 10. So both of those things are super important. You're going to learn the ins and outs. You're going to learn everything you want to know and some things you don't want to know about confidence intervals. You are also going to learn how to calculate what sample size you need in order to get your proportion within a specific margin of error. So we're going to figure that out as well, looking at sample sizes and confidence intervals. And this stuff is super important and very relevant. So let's get going. You already know point estimate. We've done this before. This is kind of a reminder. So remember, this is from 8.2. So 9.1 corresponds with 8.2 stuff that we did. So the point estimate is just the number of successes over the total number of your sample or your trial. So if I took a sample of 500 people and 300 of them had a certain characteristic, I would do 300 divided by 500, and then you would have 60% of all people have this characteristic. So that's what your p hat is. Anytime something has a hat on it, it means it's an estimate. So this isn't new. Just thought I'd throw that in there though. Okay, we don't even need that. Okay, so this is the important stuff. So confidence interval. So if I don't know the population parameter, if I don't know like what the information about the whole population, I can construct a confidence interval that is likely to capture the actual true value. So, for example, when we have polls, like let's talk about the presidential polls. That's only a few months ago. So when we had presidential polls, you could see that a certain candidate had 38% of the vote, plus or minus 3%. So what they're saying is, did I say 38%? If I said 38% plus or minus 3%, it would be somewhere between 35% and 41%. So the actual true value is somewhere in between those two values. So what we're giving is a range in which the actual proportion likely exists. So our level of confidence. So we need to have a level of confidence. We never see this in polls. They don't ever show this. But if I want to be 99% sure that the interval that I create contains the actual population parameter, then my confidence interval is going to be a little bit wider and I'm going to have certain math I'm going to do with that. Now, let's say let's say I only need to be 90%. I can have a little bit smaller interval that would contain it, but I'm only 90% sure that it is in that interval. So my level of confidence just tells us how sure that that interval actually contains the population parameter. We're going to dig in a little bit deeper. Hopefully you'll understand it by the time we're done. So here we go. Okay, so here, if I have a 95% level of confidence, if I constructed 100 different confidence intervals, I would expect that 95 of them would contain my parameter, would contain the actual population proportion. 5 of them would not include that. So there's a question in your next quiz, I believe it's quiz 6, that asks what that 95% means. This is what it means. So if I was constructed 100 different confidence intervals, 95 of them would contain the actual population parameter. All right, come on. Okay, the way that we write it, one of the ways that we write a confidence interval is we would have our point estimate. So this is our, this is our sample proportion. I don't know what the heck just happened. Where did it go? Okay, let's try it again. I don't know where it went. It just kind of disappeared. Okay, well, I'm just gonna have to open it once more. I don't know what happened. It does that every once in a while. There we go. One more time with feeling. Okay, where are we? We are right here. Okay. Once I create my confidence interval, this right here, I still have a highlighter on. Let's get the pen. This right here would be the point estimate that you got from your population or your from your sample, sorry. So this would be the proportion of your sample that contains a specific or that are have a specific characteristic. So this would be the sample proportion. It's your p hat. So that's your p hat. The margin of error, this is telling me how far away from my point estimate the edges of my confidence interval are. So the way that it is, so for example, this would be my point estimate. This right here is my p hat. And then I would have a value that would extend like to here and here. I will tell you how to get there when we get there. And I would say that I think that based on my math, I am 95% sure that the actual population proportion is somewhere in this region. So that's basically what we're doing. We're figuring out what is the, where with or what is the region in which my population proportion is likely to be. So 95% sure means that if I created those 100 confidence intervals, 99 would contain the population proportion. If I did a 95 would, if I had a 99%, then 99 of them would contain it. So this is basically what we're doing here. So these are the three things that we're going to look at. We have our level of confidence. As my level of confidence increases, once again, I'm on a highlighter. I don't know why I keep getting on a highlighter. As the level of confidence increases, the margin of error is also going to get bigger. Because if I have a 99% confidence interval, then that interval is going to be larger. That region is going to be larger. If my sample size gets bigger, and sampling more people is going to give me more accurate results. Therefore, my margin of error is going to decrease. My margin of error, my region that the population proportion is going to be is going to get smaller. So if my population is more spread out, my confidence interval will also be more spread out. We don't really, this is really the only time we talk about standard deviation in this section, but this is just for your information. If you continue on with stats later, go to 244 and then some 361s later on at university, you'll dig into it deeper. But I don't think we have any aspiring math majors or statisticians in here. So you're just going to kind of set that part aside. These two though are important. All right. So remember the standard deviation of our p hat. This is from 8.2. Looks like this. We need this right here. We only can use the standard deviation formula if we are normally distributed, which means that we have that NP times 1 minus P is greater than or equal to 10. Also, every trial needs to be the trials need to be independent. So our sample size needs to be less than 5% of the population. This stuff remains. This is the stuff that we had in 8.2. This remains. Also, our mean equals the population proportion. Our mu sub p hat equals the population proportion. So there we go. This is all the same stuff. This is just reminding you of 8.2. Okay. All right. This is the meat right here. This is the meat of it. So what we are doing. So in order to determine the edges of my confidence interval, so when I draw this lovely picture and I have these edges of my confidence interval, this right here would be my p hat. I need to figure out, I need to determine how many standard deviations away from the mean we need to be based on our confidence level. And then this right here, this is the z-score that corresponds with our confidence level. This right here is our standard deviation. So I'm going to use that z-score that I get, multiply it by the standard deviations. So that's going to tell me how far I go this way and how far I go that way. And then I'm going to add it and subtract it from p hat. So basically I'm saying the edges, so the edge might be 1.96 standard deviations away. So I would do 1.96, which would be this z-score, times the standard deviation, which is that. And then I would go this way with it, and then I would go that way with it. So I'd go to the right and I'd go to the left, and that's the edges of my confidence interval. That tells me where the edges of that interval are. Obvious,
I can
yes.
I sorry, this is a little fast for me. That can you repeat the Z, the that yeah, the smaller circle there around the A2, but you were saying
So
that's standard deviation?
no, this is standard deviation. So this right here, the P,
Oh, okay. Okay.
this is the new standard deviation right here.
Okay. Okay.
Look familiar from 8.2. I will,
Yeah, it should.
okay. So maybe just a slight, like, one of those things where you pass somebody in the grocery store and you're like, huh, I think I might know them. I don't know from where, so I'm going to hide down this next aisle. It could just be like that. But that is the new standard deviation from 8.2 that we learned. But instead of P, we're using P hat because we don't know the population proportion. So we'll be using P hat. This right here is a z-score based on the population, sorry, based on how confident we are. So if I said that was 95% confident, I'm going to use a z-score that corresponds with that. And I'll tell you how to get that and what we're doing with that. It's not really different than what we've already been doing, but we're a new topic. I understand this. So just like if I was, so let's step back to a previous to like empirical rule. Remember when we said that 95% of all data is within 2 standard deviations of the mean? So when you were doing your empirical rule, you would do, hold on here, just a second. Okay. So when we were doing your empirical rule, I would have mean, I need a pen back. Mean, and then I would add 2 times the standard deviation. Then I would subtract 2 times the standard deviation. We're basically doing the same thing, but this number, this 2, instead of this 2, we're using a very specific z-score, and we're multiplying it by the standard deviation to determine how far away from the mean we need to be for our confidence interval. Hopefully, once we start doing it, it'll make sense. So it's hard when there's no numbers and I just throw formulas at you.
What's the A of two mean? Like, what's the A slash two mean?
That's the next screen.
Oh, okay.
So it's good question, but I believe that's the next screen. Not quite. It's the screen after that. All right. So actually, this is basically this screen. This is from the textbook. I just really liked it. So I took it out of the textbook. So basically what's happening here. So remember long time ago in last chapter when I would say find the center 90%. I would say find something with the center 90%. 5% is up here. And then 5% was down here. This is basically what this picture is saying. Therefore, I had to use inverse norm with 0.05 and inverse norm with 0.95. Is this ringing bells? It should be ringing some bells. Okay. So, therefore, this right here, this 8 alpha divided by 2, what this is saying is that the difference between 100% and 95% or 90%, hold on, I didn't mean 95, I meant 90, where's my arrow? Okay, and 90% for this middle 90% was 10. I divide the 10 by 2 to get that there's 5% in each tail. I'm getting a z-score based on this 5%. That alpha is the 10%. Then I divide it by 2 to get a z-score based on half of it because I had to use the center 90% or center 95 or whatever percent we're using. So that's what that alpha divided by 2 is it's half of what's left of what's the total left in the tails. You'll see once we start doing the math. So this value that we find, this z-score right here, it's called a critical value. That's what that z-score is called. Well, both of them. Both of them. But that's what it's called. It's called a critical value. So it just represents how many standard deviations away from the mean we can be and still be within our interval. I know this is a lot. Once we start mathing with it, it's going to be a little bit easier. When I'm throwing all these random letters and symbols, it makes it tough. So let's move on. Okay, so this is the one in the pages of your textbook, but then in the back we have a prettier one. So I'm going to actually go to the one at the bottom of your Z table. So at the bottom of your Z table, that front page, we have this right here. This is the usual critical values. These are the ones you're going to see the most. You're going to see your levels of confidence right here. So if they say I'm 90% confident, your critical values, your Z alpha divided by 2 is 1.645. If they say we're 98% confident, then you're going to use 2.33 for your critical value. So it's really nice. These are all right here. But if they give you a weird one, every once in a while, they'll give you a weird one. You can just use inverse norm, but you have to cut it in half, that difference. You have to cut it in half. So for example, because we only use positive, by the way, we only use positive, only use positive z-scores. So for example, let's say I wanted 80% confidence. Let's say I'm 80% confident. Okay, then my tails, 80%, I have 10% up here and 10% right there. I'm going to use inverse norm with 0.90 because that's what this is. That's what the z-score right there is for. 0, 1. And this will give me the critical value. Questions so far? Okay.
I have a quick question, really quick. Sorry, I couldn't get my audio on really
No problem.
fast.
Okay.
So the inverse norm, you do that formula, and then you still divide that in half.
No, because this is the half of what's left. This is what's left.
Okay.
So I have to divide it in half before I go to inverse norm. Don't panic, Kate. Don't. No, your head hurts. It means you're building new connections in your brain. So we got this. We got this. Don't worry. This is not too bad.
Can you just say again where the 0.9?
So this is just like when we were doing the center in last chapter, I think it was last chapter, when we were doing inverse norm or normal CDF. I think it was the one before. So if I have the center 80%, then this is at 90%, right? And then this
Ah,
10,
okay. Yep.
I'm going to use inverse norm with 0.90 because
Okay.
I'm looking for this z-score right here. I'm looking for the z-score that's right there.
Okay.
Use inverse norm with 0.90. It'll give me a z-score, and that's what I'm going to use as my critical value.
When you do that, would you have it
Brittany.
look for the left tail then still?
The thing is it doesn't matter which one. Yeah, yeah, left if or as Courtney just said in the chat, if you have the center, you can use 0.8 with center. But
Okay, that makes sense.
yes, but you're going to what's I going to say? You only want the positive, only the positive z-score.
Gotcha.
But most of the time, these are the ones you're going to use. They very rarely use any other ones, but sometimes MyOpenMath does things finicky. But I know we just had a test, but I can absolutely tell you on the next test, I'm not going to use funky numbers. I will stick with one of these in this table. But yes, if you have the center function, you can use 0.8 with center and then just use the z-scores that you get. All right. I think we're about ready to math. This is we already said this. I'm gonna move on. Okay. We're gonna step this piece by piece. You're gonna be okay. All right. In July 2008, a Quinnipiac poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for people convicted of murder. 1123 were in favor. We're going to get a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for people convicted of murder. So, first thing I'm going to do, I'm going to jump back here because I don't have my Z table up. And I'm going to erase all this stuff because there's a lot of stuff on here we don't need. Okay. For 90%, come on, give me my pen back. For 90%, my z-score is my critical value is 1.645. So that's the z-score I'm going to use because it's for 90% confidence interval. Okay. 1.645. So my z sub alpha divided by 2 is 1.645. Okay. Now my p hat equals 1123 divided by 1783. And I want to get that in a decimal. Just because. So this is approximately 0. I'm going to do 0.63. So it's 0.6298. So I'm just going to do 0.63. All right. So I've got my p hat and I have my z-score. All right. So here's what's going to happen. I'm going to draw a picture. I'm going to draw a picture and then I'm going to delete it because I need the room. Okay. My p hat is right here. And then what I'm going to do, this is my p hat. What I'm going to do is I'm going to add 1.645 times whatever my standard deviation is to go this way. And that's going to be the top edge. Then I'm going to subtract 1.645 times my standard deviation to go this way, and that's going to give me that side. This is what I'm doing to create the interval, is I'm adding 1.645 standard deviations to the right, and I'm subtracting 1.645 standard deviations to the left. Okay, let's math it out. Okay, my standard deviation. Now you can do all of it in one big math swoop, but I'm not going to do that because I kind of want to baby step through this because I can just put all of it in my calculator all at once and get numbers, but I kind of want to baby step through this. So we're going to do our standard deviation sub p hat, and it's going to be, so my p hat is 0.63 times 1 minus 0.63 divided by my sample size, which is 1783. and I want to get this number. Okay. Uh-oh. Need to turn on a light. Zero point 0.0114. Tell me if I got if you put this in your calculator and got something different. I'm going to turn a light on. Okay. Now, I have everything I need now to create my confidence interval. So for my upper bound, actually, hold on a second here. I'm going to calculate the margin of error. We usually just write it like this, or just a capital E. I usually do ME for margin of error. That's the margin of error. Okay. So I'm going to take the standard deviation, or the critical value, times this right here. I don't know why I did times like that. So it's about that. This right here is the margin of error.
Can you write the formula for that out where you got the 1.645 and the 0.014? Thank you.
You're welcome. Times. So it's that critical value times the new standard deviation. That's my margin of error. So I think I might not have had enough zeros. No, I do. It just, for some reason, that number seems big. I guess I'll find out in a minute when I go to the next screen. All right. So what I have, what my margin, what this looks like is, and probably because I have a small sample size anyway. So my upper bound is going to be 0.63, which is p hat, plus my margin of error, equals 0.8175. That's my upper bound. My lower bound, I feel like I did some math wrong somewhere. We'll find out in a minute. 0.63 minus 0.1875. 0.4425. You got 64859 for what? For which one? For the upper bound? Did you have a different number for your I think I just feel like my margin of error somewhere I went wrong on that. Is there a zero in there I missed? Oh, I see what no, wait. No, I got did somebody can someone confirm the upper bound?
I also got 0.64875, at least when I just added the 0.63 plus 0.1875.
0 point, okay, hold on a second here. Oh, that should be okay. See, that's my problem. I knew that something was wrong. Oh, I lost a zero. Okay. Thank you, Courtney. I was like, I knew something was wrong. Okay, I apologize to all of you. when I put it in my calculator, I missed this 0 right here. Okay. I was like, something's wrong here. I knew something was wrong. Thank you. Thank you so much. Y'all are rock stars. Okay. When I put this in my calculator, my margin of error should be different. It should be 0.01875. I knew something was wrong. I was like, what is going on here? Okay. Once again, whew, thank you. Another example of your math teacher is human. So 0.63 plus 0.01875. There we go. It just was like that number is way too big. I don't know what's wrong. Okay. I don't know what I would do without everyone in this room. Okay, and then this upper, my gosh. Okay, minus 0.01875. I knew something was wrong. 18875. Okay. 0. This is so much better. Okay. So the different ways that we can express our confidence interval is sometimes we will put it in a bracket like this. I would say my lower bound to my upper bound. This is one way that my open math will have you express it. The other way that they'll have you express it, so this right here is just lower, upper. The other way that they'll have you express it is p hat plus or minus margin of error. So it'll look like this, 0.63 plus or minus 0.01875. So these are both answers. Those are just two different ways to express it. So if you were going to write a sentence to state this, you would say, we are 90% confidence that the actual percent of people who are in favor of the death penalty for persons convicted of murder is between 61.13% and 64.88%. So you would say we're 90% confident that the actual is between these two values. So I'm going to show you the typed up proper math without the errors. Okay, so here's what they did that I didn't do. We need to know that NP times 1 minus P is greater than or equal to 10, which we got right there. And we need to know that the sample size is less than 5%. We have that there. And they showed me there's Z sub alpha divided by 2. We got that. Okay. And technically, you can put, when you have numbers here, you can put the entire thing into your calculator. How come it doesn't show the math? I don't know. Okay. So these are the same numbers we just did. And here's what they got right there. Which this is what we got also. We just rounded. We didn't round to 2 decimal places. We went to 4. So they're saying we're 90% confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 61 and 65%. Questions before we do another one? All right, we're going to do another one. And I'm going to give you the calculator function. You didn't see this. You didn't see this. I'll give it to you in a minute. We're going to do this by hand and then I'll give it to you. I don't know. You can look at it. You can look at it. All right. So once again, so the Gallup organization conducted a poll, a simple random sample of 1,016 Americans were asked, do you consider the amount of federal income tax that you have to pay is fair? Of the 1,016 adults, 558 said yes. First thing is your p hat. I have approximately 0.55. That's my p hat. Okay. Going to do our z sub alpha divided by 2. So once again, I'm going to draw the picture. If this is my center 95%, there's 2.5% here and 2.5% there. Therefore, this is 0.975. So if you're going to use your inverse norm, you're going to use it with 0.975. Or, can go all the way back. I'm going to excuse the speed. Oh, I went too far. Or we can go here. 95%. 95% is right here. So it's 1.96. Okay. That's the z sub alpha. Let's go back. Okay. I do love the z table though. It's just something nice about being able to look on the table and see it. All right. Now I'm going to calculate the standard deviation. So my p hat times 1 minus my p hat. I don't know why I put a 0 on one and the other. Divided by our sample size. So it's about 0.0156. Right. Have I lost anyone yet? Are we still good?
Can you show me how you found the z-score, like the second one under the b hat?
Yes. Let me go back to the, whoop, that's not where I want to be. Right here. I just looked at the 95% right here on level of confidence because it's a 95% confidence.
Oh, okay. How would you find it if you didn't have that? Like if it was odd, how would you do that?
I would use so drawing this, the middle 95% is in here. So I have 2.5% left here and 2.5% left here. So this z-score is at the 97.5% mark. So I would do inverse norm 0.97501, and that would give me that z-score.
Okay, thank you.
You're welcome. Let me get rid of this. Okay. Now, what we're looking for is p hat plus margin of error and p hat minus margin of error. This is our goal. I still need to calculate the margin of error. So for my margin of error, I'm going to actually go down below. I have room. Margin of error is going to be z sub alpha divided by 2 times sigma sub p hat. So it's going to be 1.96 times 0.0156. This is going to be my margin of error. So it's just telling me the z-score times the standard deviation. That's good enough. All right, so this right here is my margin of error. Okay. Now let's do the thing. Let's do the magic. Okay, purple's good. So my p hat is 0.55. This is going to be upper. So 0.55 plus 0.0306. I swear I am going to not make a mistake with my calculator. Not going to typo this time. So I have 0.5806 approximately. My lower, 0.55 minus 0.0306. Zero point 5194. Okay. I'm going to put the two ways of writing it. I'm going to put it up at the top because I'm kind of out of room. So I can either write it like this, or I can write it like this. Those are the two different ways that I could write this. Usually, this one right here is how we see it in like presidential polls and things like that. I would see that, this candidate has 55% of the vote plus or minus 3%. That's basically what that's saying, is that whatever this is, they have that, well, so the people who believe that they are paying, that what the amount of income tax they pay is fair is 55% plus or minus 3%. Or we can say that we are 95% confident that the actual percent of people who believe that they pay a fair amount of federal income tax is between 51.94% and 58.06%. Usually I would say between 52 and 58. I would do some rounding there, but it really just depends on what My Open Math wants you to do. Listen to them, they're the boss. Okay, you guys ready to do a calculator function? Get your fancy ready. Let's find, there it is. Okay, so we're going to use something called one prop z int. Or interval. So it's one proportion z interval. That's exactly what it stands for. So we're going to go to stat, the stat button right here. We've been here before, and go over to tests. So stat, arrow over to tests. You're on this crazy page right here. And we're looking for one proportion z test or z interval, one proportion z interval. So it's way down here. It's letter A. One proportion z intervals right there, letter A. It just says int here. It does, the whole word interval doesn't fit on my screen. But when I click on it, actually it still doesn't say it. So what it wants from me is it wants the number of people that said yes. So it was 558. And then it wants the number of, or the sample size, 1016. That's my sample size. And it wants the confidence level. My confidence level here is 95%, so 0.95. That's all it needs from me. So I'm going to hit calculate. And what it gives me this right here. It gives me the, now obviously because they don't round, their numbers are slightly off of what mine are, but it's going to work because it's still 52% and 58%, which is probably what you're going to get in My Open Math. But what it doesn't tell you is the margin of error. It only gives you the p hat, and it gives you the upper and lower bounds. So I'm going to show you. Let me write it on my page here. I'm going to write down what they have. Hold on, I need room. I need a blank page. Okay. I'm just going to use this next blank page, so don't worry about it. So I'm going to write this down. 0.51862, 0.57981, and then it gives me my p hat, 0.5492. Okay. So if let's say that My Open Math wants this as p hat plus or minus margin of error. This is what they want. Even if I don't have the p hat, so I'm going to even get rid of this. Sometimes they're just going to give me this right here and tell me to rewrite it like that. So we know that the number smack dab in the middle is the p hat. It has to be. It is the center of my interval. So I would do 0.51862 plus 0.57981. I would divide it by 2. That's going to give me my p hat. I have it, but I'm going to still do this math. That gives me a p hat of 0.5492, which is great. Then in order to get the margin of error, I can just take this top number, right here and subtract the p hat from it. And this is going to give me my margin of error. Because the margin of error is how far away from your p hat you are, right? Okay. 0.57981 minus. So I have 0.03. I'm just going to 0.6, I guess. Yeah. So you're just going to have to kind of work backwards a little bit in order to find that, in order to find the p hat. So this would be this number plus or minus that number is how you would write that. So you're just kind of working backwards. Questions about that? All right. So this is the margin of error formula. We've already been doing this. It's just the critical value times the standard deviation. We've already been doing that. Okay. We're going to move on now to sample size. Are we okay? Haven't made anybody super sad yet? I hope.
I just want to make sure I just wrote this down. To find the p hat there, it's just the lower value plus the upper value divided by 2, and then the margin of error is the upper value minus the p hat.
Yes,
Okay.
exactly. Beautiful. Good job. Okay, let's find sample size. So sometimes we know the margin of error we want because we want it to look good. I don't want to end up with a super large margin of error. So because it's going to be less credible. If I had a margin of error of 20, it's going to be a lot less credible than having a margin of error of 2%. So 20% and 2% very far away from each other. I don't want that big of a margin of error. So sometimes I need to figure out, how do I get a 95% confidence interval with a 3% margin of error? And it all comes down to sample size. So if I have a large enough sample size, I can get exactly what I'm looking for. I can get the exact margin of error and confidence level that I'm looking for. So sometimes we have to work backwards. So the problem here is that if I haven't already taken a sample, I don't have a p hat yet. So this is where this gives us a bit of a conundrum. So there's 2 different ways that we can figure out what to use the p hat. So this formula right here, this is the critical value. And this right here is my margin of error. And this is what we need to figure out. How do we get a p hat that we can use so that I can figure out how large my sample size needs to be? So I have 2 different ways to do that, and I'm going to show you in a second. Okay, let's move it. All right, 2 different ways that we can do that. Number 1, you can use a prior study. So let's say last week I took a poll, and the poll said a certain candidate had 43% of the vote. I'm going to use that now to determine the sample size for my next from my next study. So it is one, basically it's like a previous study that's not likely to be too far off of our current study. So sometimes if we give you a previous study, this is what you're going to use. If they don't give you a previous study, we're going to use p hat equals 0.5 because it's going to give me the largest possible value. And I'm going to show you there's a big difference between using 0.5 and using a previous study. But if I don't have a previous study, my p hat's going to be 0.5, just the way it is. So these are the two different ways to do this. All right. And always, this is very, very important. We always round up to the next highest number. I can't have a sample of 38.6. I can't. I have to round it up to 37. I have one. I have a cheat sheet. Don't worry. I believe it's at the end of Thursday because we're going to be doing and I actually think, hold on a second here. It might even be in, let me go back to Blackboard. Okay, let me see. No. Where is it? Okay. Let me see here. Go into, what week are we in? Week 8. I think if I go into the chapter 9 materials, yes, no, yeah, here, right here. See this handout right here? When you click on it, this is going to give you both today's and Thursday's information. And it breaks it all down for you. Except for it doesn't do the sample size. So if you print this, oh no, here it is on the second page. There you go. This is the sample size stuff. So they're both here. If you print them out, you can write your own notes on top of it. And also on the last slide on Thursday, I go over it again and tell you the difference between the two things. So I've got your back. Okay, so my example that I use a lot for these, this is, let's say that I have 175 students, okay? I have 175 students and each bus can hold 80 students. I have to, I could two buses will fill 160 students. I still have 15 kids left. For safety, I can't shove them on the other buses. I still need that third bus. So it's this kind of the same thing here. If I took a sample size, or I calculated this and it said that it was the sample size I needed was 105.2. 105 is good, but it's not going to give me my margin of error and confidence level that I need. I have to round up to 106. Always round up to the next integer. Always, always, always. Okay, let's math. So this right here, you don't necessarily need to do this. This 0.25, that is just 0.5 times 0.5, which is p hat times 1 minus p hat when we're using 0.5. We just put this here because you know that 0.5 times 0.5 is 0.25 and we just call it good. But you don't have to write it that way. Let's do this. Okay. A sociologist wanted to determine the percentage of residents of America that only speak English at home. We want to know what sample size we need if we wish to have 95 or 90% confidence, and we're looking at a 2000 estimate. So this right here is going to be our p hat. So we're looking at an old estimate. I don't remember the z-score. I'm just going to use inverse norm because I'm too lazy to go back to the other thing. So 9. I think I have it memorized, but I can't remember. Yeah. So my z sub alpha divided by 2 is going to be 1.645. I don't know why this is the only one they round to 3 places. I have no idea. However, I do want to tell you, I don't know if it's this chapter or chapter 10. One of them tells you to round your z-score to 2 places. Make sure that you make that 1.65 at that time if you do. Just letting you know. All right. And here's my margin of error right here. So our formula, remember, p hat times 1 minus p hat z sub alpha divided by 2 over margin of error squared. This is what we're going to do. So I'm going to do n equals, my p hat is 0.824 times 1 minus 0.824. My z is 1.645. My margin of error is 0.03 because that's 3 percentage points squared. You can put this entire thing into your calculator. Put it all into your calculator. I'm gonna do it here because sometimes putting things in calculator can be complicated. So I'm gonna put it in here. So I have 0.824. I need to make this smaller so I can find my parentheses. Parenthesis 1 minus 0.824. Close that parenthesis. Open a new parenthesis. My z is 1.645 divided by my margin of error 0.03. Close the parentheses, then hit the x squared button. $436.04. That number is so close to 436, but you have to round up. No choice in the matter. We have to round up. Always round up. Give me whole numbers. Always round up. Questions before we move on? So my sample size has to be 437. This is going to give me that 3% margin of error and a 95 or 90% confidence. And there it is right there. So the sociologist must serve 437 randomly selected residents to get what they want. We're almost done. We have one more slide. One slide left tonight. All right. An economist wants to know the proportion of US population that commutes to work via carpooling. So we want to see within 2 percentage points of the true proportion. We're estimating 10% from a previous survey, and we have a 90% confidence interval. Thankfully, I remember from last time, 1.645. My margin of error, 0.02. And this right here, my p hat is going to be 0.1. Okay, let's do this. Oh, I hate when it does that. See, it shows up upside down on mine when it does that. I'm gonna give y'all a second. I don't want to have an answer before you. You get 608.86, so that means 609. Did we get there? Good. Now, what if the economist doesn't use any prior estimates? So if they don't use a prior estimate, remember, we do this. Math that out. Take a look at the difference.
Wouldn't it be 0.5 times 1 minus 0.5?
Yeah, but 1 minus 0.5 is just 0.5, so I just put it.
Oh, gotcha. Yeah.
If you want to put it that way in your calculator, that's fine. I'm feeling a little lazy. I think your blabbers are gonna be gasted at how big the difference is. Look at the difference in sample sizes. So whenever if you can use a previous sample, a previous proportion, it's a really good idea. More than 1,000 people different. That's a huge difference. So it definitely is a good idea if you can find a previous survey to use that. Right. So questions, I think the next one's blank, yeah. Questions while we are on the recording. Any questions?
If you're using data from a previous survey, how do you relate that to what like the true numbers would be for today?
Um, it pretty much the thing is, I don't even know. I don't even really know how to answer that. It's really just about saying, it probably hasn't changed that much. I probably wouldn't use a survey that happened too long ago. I'm not going to use data from 35 years ago, but I might use data from like a year or two ago. I think the rationale behind it is it can't possibly have changed that much in a couple of years. And everything is an estimate anyway. All of this is just an estimate anyway. So I think we're just assuming it hasn't changed too much. And that's the thing is we statisticians don't deal in absolutes. So this is not an exact science. It just kind of gets us there. Yeah, and that probably wasn't a great answer, but it's what we got.
Do we need to collect any lab data for Thursday?
Thursday's lab, you can just use your continuous data from lab 1.
Okay.
You just use the continuous data. What we're going to be doing is using Excel to create confidence intervals. So it's super easy and fun. It's just using stuff you basically already know. So it's kind of cool.
So we don't need to like collect anything new.
No, in
Okay.
fact, the lab is probably going to take you the work of it is probably going to take you 8 minutes. It's super fast. It's a really quick lab.
Are you going over that on Thursday, or is that something we're gonna do by ourselves?
No, I will go over it after the lesson on Thursday.
Okay. Thank you.
You're welcome. Good questions. Anyone else? Okay. I'm gonna
I
turn.
have questions about the project.
Okay, I'll leave the recording on because this might, unless it's specific to yours.
Well, it kind of is, but I don't,
Okay, I'll just leave it on. Go ahead.
okay, it's not. I could see somebody else having similar questions. I don't know. So I've been really sick, so I'm just trying to catch up on collecting my data, and I've had I keep getting really frustrated with trying to find data that represents the questions I would be researching. So my most recent topic is asking questions about the homeless population across the US and correlations to income, poverty, housing rates.
Love that.
So I have all 50 states, so 50 data points.
Perfect.
And what I'm questioning is, what are you considering usable raw data? A lot of times I can just find numbers, but sometimes it's rates per like homeless, the rate per 10,000, and then it gives me a percent, but it's by state. Is that raw data?
Yeah, yes. Yeah, I don't need like every single person. So that is raw enough. Just make sure that you communicate somewhere in your project where you got your data. So
Okay.
you want to, and this is not an English class. So if you're communicating, like, for example, you're going to put it on probably what you submit that's due today, but
Yeah.
guys can use late passes, just letting you know. The data is due today, but I do allow late passes on the data. So it's okay if you use a late pass on that. So that gives you 48 hours if you're not ready. But I believe that it says that one of the prompts is how you collected your data. Just a second, let me go to that page. How you collected your data. I want to have the perfect of the actual real words. Where is, how come it's not scrolling? Where's my final project? Somewhere. My page is different than yours, so there's my final project. Okay. So the assignment sheet, what you are submitting tonight, make this bigger. What you're submitting tonight, or if you, within the next 48 hours, if you use a late pass, it says description of how data was obtained, sampling methods, sources, possible bias. So if you didn't collect the data, like you didn't poll your Facebook friends or ask people standing outside the grocery store or whatever, you're going to be dealing with sources. So you're going to say that you got it from census.gov or you got it from whatever, wherever you got it. Providing a link is a really great way, or you can just say the census website. This isn't super scientific as far as how it's presented. I'll leave that to your science classes, but I do want to know where your data came from. And possible biases is just basically maybe they weren't, especially homeless data, all the reasons that they can't count homeless, there's a ton of reasons. So you can just, for possible biases, you can say things like, you know, a lot of homeless don't want to be counted. It's really hard to find the homeless. That for something like yours, that would definitely be a bias, right?
Yeah, could you explain, or is that all I would need to know about biases? Because I hadn't gotten that far. I've been like dying with whatever this is.
We haven't gone too deep into biases. So I just want you to kind of think about what are some reasons this data can be wrong. And I'm not going to like dock you for having data that could have issues. I just want you to say this issue could exist. And sometimes you don't know of any issue that could exist, and that's not a big deal. But especially something with homeless data, there's definitely issues with how do you collect data on homeless. So I'm just really kind of want you to think about, how good is the data that you collected? And I don't even care if you got data and it's kind of not very good, as long as you state something like, you know, that probably not on yours, but there could be other things. Like I was standing outside the ice cream shop when I was polling people, so they probably do prefer this ice cream shop, weird things like that. So, and I do want the statement about why the data is interesting. So Kate, you said that you just put the raw data. You can still go back in because it hasn't closed yet. You could even submit a second sheet if you wanted to, or resubmit, or you can type in the view work. I don't care how you do it. You can do either one. The show work page. Yep, you can do either one of that. So this is all the things that are due tonight is just this. And yeah, obviously late passes if you need to. Did that answer your question, Ellie?
Yeah, thanks. And then could you give us an idea of like with all of the formulas we've used and ways to look at data, like I'm thinking the things we're learning like tonight, like I don't think this applies to our project data. Like what is typical for us to use?
Okay, so I don't want to give you too much because a big part of what I'm grading you on is you choosing your own analysis methods. I very rarely have anybody use confidence intervals. I mean, you could technically use it and say, now here, my sample here, I mean, maybe not yours, but somebody who actually sampled people, you could, you could definitely say, here's my sample size, and I think that the actual population proportion is in between these two values because you're sampling and applying it to the whole population. So somebody could do that, but it's not common to use tonight's. And even the stuff that we're learning next week, not super common for people to use. People use regression a lot. They use the chapter 4 stuff a lot. They'll do means and standard deviations, and they sometimes will do bar graphs. Occasionally I get pie charts. I mean, pretty much something out of each chapter you could choose. You could also look at it and say, my sample, I mean, maybe you found a website that has specific information that says, you know, 58% of people prefer Baskin Robbins over Dairy Queen, and say, hey, but in my sample, I got 85% preferred Baskin Robbins over Dairy Queen. I'm going to do a binomial probability distribution to say, what is the probability that I would get that? I mean, it's not common. Most common things are comparing means and standard deviations, doing linear regressions, and doing some really nice, maybe bar graphs or pie charts. Sometimes people will break it down into smaller pieces, and say, like, maybe they break something into male and female and then compare those also. There's Take a look at the samples, and there's a lot of different ways that people did things in the samples. It's probably my best advice to you. That was a lot. Sorry.
And then I have a question about tonight's work.
Yes.
Is the margin of error, is that describing, like, so because we have pretty exact numbers to find p hat, we're given, like that fraction.
Mm-hmm. Yeah.
So what is the margin of error saying that, like, this, because this is a sample, this doesn't completely capture population
What is
proportion?
So what the margin of error says is that, so my sample is, I'm going to say 50% because it's a really easy number for me to not forget before I quit explaining it. So let's say that my sample had 50% of something. 50% of the people in my sample have a certain characteristic, whatever that is. So the margin of error is going to say that 50% plus or minus 3%, so up to 53% and down to 47. So the actual population proportion. So the people in the entire population that have that characteristic are going to be between 47% and 53%, because I only have sample data, but with the math that I did, I can tell that um, there's a 95% chance that the actual population proportion of this is in between those two values. So the margin of error just tells me how far away from the p hat I can get and still be in that interval and capture the population proportion.
All right, that's exactly what I was asking. Thanks.
Good. All right. Anybody else for while we're on recording? I'm going to unrecord, and then I'll turn the recording off.